are you? I hope everyone is fine. This is our lecture number 80, and this is the continuation of the previous topic, waves, right? In this particular uh, in this particular topic, in this particular video, we're going to study about electromagnetic wave and what is meant by electromagnetic spectrum. Now, till now, we were just talking about electromagnetic radiations and all that, right? The radiations which are coming from the sun are named as electromagnetic waves, which do not need medium to travel, right? But every wave we are generally call them light, but actually they are not considered to be a light. All the radiations are basically uh, moving with the speed of light, which is 3 into 10 raised to the power 8 meters per second. Now, if you see that light that is coming from the sun, technically speaking, that light is basically divided into different frequency with a different type of waves, different waves. Some waves are high frequency, some waves are less frequency, depending upon. So we call that range of waves or range of these different frequency as electromagnetic spectrum. Each particular wave having specific frequency range is used for different purpose. So these all waves do not need medium to travel, right? So region will be occupied as range from higher frequency to a lower frequency, or you can say higher wavelength to a lower wavelength. Now the name we have it are radio waves, microwave, infrared, visible light. Now this is a light which we can see like red, orange, yellow, green, blue, indigo, violet. And then we have ultraviolet, X-rays, and gamma rays. Now this is the order of being like from lesser frequency to the higher frequency. So radio wave has the least frequency, while gamma rays has the most highest frequency in this whole electromagnetic spectrum. While as far as wavelength is concerned, radio wave has the highest wavelength. So wavelength is the highest, but frequency will be the least, right? So this is how the things are. The diagram shows very interesting some facts if you just check this out. Now, what is that diagram showing? Check it out. In this diagram, you can see that here, while it goes from left to right, from radio waves to the gamma, the frequency will be lower, right? Number of waves passing in a unit second is lower, and you can see the wavelength is larger. But as it goes from left to right, the wavelength becomes smaller and the frequency becomes increased and increased and increased and increased till it reaches to gamma radiation. Now, another very interesting fact is low frequency waves have a less energy, while high frequency waves have a high energy. So it means that gamma radiation being the high frequency are the most energy waves, right? Now, properties. The first property that is common in all of them are they can easily pass through the vacuum because they are moving with the speed of light. And they are all transfer waves. Like they are moving in such a way that the particle of the medium travel perpendicular to the propagation direction or movement of the wave. And all the waves are moving with the speed of light, which is approximately, definitely, it's just approximate value. Now, let's talk about the uses and then we talk in more details. The radio waves, as being the lightest frequency and the heaviest or highest wavelength, these radiations, which are radio waves or some microwave, they are used for radio and television communication because they can easily bypass the obstacles and all that. Astronomy also they are used for. So communication basically is a major purpose for that. And radio frequency identification it are used for as well. Microwave, so satellite communication, mobile communication also. Microwave use these radiation to cook food as well. Then you got infrared radiation. Now, this is electric grill is used that television remote controls are using that infrared radiation to actually turn on and off the television or changing the program. Then we have thermal imaging as well. The image that is used to actually by using the heating thing or sensing the heating thing, this infrared radiation is used for. Optical fiber use this infrared radiation for them as a movement of data from one point to another, right? Visible light. Now, what is visible light? Visible light is a specific range of light which we can see, whichever we can see through the naked eye. The colors are red, blue, green, indigo, and all that. The this light comes in. Then we got the ultraviolet radiation, which is considered as a security marking and detection of the fake notes it is used for. Plus, it is used for the sterilizing water as well. The last waves are X-rays. They're using for the medical purposes and also for the security scanning as well. Right now, the last one is basically the gamma radiation used for the you can say sterilizing food, medical equipment. If you want to clean it, you can clean it through that. Plus detection of cancer as far as treatment of the cancer as well. This is used. Now, quickly, one by one, we will see their uses. We already see, but let's see in more like detail one. Warm object emits infrared radiation, so we can find that object by using this infrared radiation. I'm talking about the infrared one. Then definitely those there are cameras that can easily sense that thermal imaging, and we call them thermal imaging cameras. So thermal imaging cameras use that infrared radiation to sense a person there. Then in security camera for research and also in the medicine it is useful. Plus in remote controls there is a LED, infrared LED that actually emit out the infrared radiation, and that is used to turn on and off the TV device. It is also used in the fiber optic cable where data communication occurs in the form of infrared radiation. Then remember that in general cases, radio and microwave are considered to be the same because they are used mostly for the communication purposes like Wi-Fi, radar, mobile phone. Some of the microwave is also used to cook for heating purposes as well. You're talking about a visible light. So visible light is the light that human being can see. So this is the light used to illumine something, right? So visible light got everything to do with the human eye. You want to see something, you have to have this light, like colored one, red, green, yellow. Then we have ultraviolet, right? Now, ultraviolet one are used for different purposes, like fluorescence. Now, fluorescence is like lightning. So for lightning purposes, you can use it for. Now, most bank notes have invisible fluorescent marking on them. So even we can use to detect the fake notes by using this ultraviolet light as well, right? Ultraviolet responsible for giving you a stun tan, especially in the sunlight. Afterwards, we have X-rays. They are quite penetrating, but they have medical purposes. X-rays can easily pass through the tissues, but absorbed by the dense body parts such as bones. So bone absorb that, and you can have the X-rays through these X radiation. The last but not the least was the gamma radiation. Now, gamma radiation being the highest frequency, they are used for the medical purposes like treatment of camera and even to detect the cancer. It is also used for. Now, there are some dangers as well, definitely. Remember that being the light or very less frequency, we didn't find any any particular damage occur by the radio radiations. But for microwave, yes, internal heating of the body cells can occur for humans. Infrared, yes, skin can burn. Ultraviolet, they are quite penetrating. So damage the surface of cell, eye, skin cancer can occur. And the last one is mutation of or damage. Mutation means the cells can be damaged cells, or you can say infected cells that can cause cancer and all that through X and gamma radiations. So harmful excess. Now remember one more thing. In general, if the radiations are in less quantity, you may be safe, but it occurs when there is an excessive exposure to these radiation, whether it's a microwave as well. If there is excessive exposure to microwave radiation, what can happen? Frequency of a microwave is absorbed by the water molecule, so risk of internal heating from the microwave, right? And this may worry some people, but the longer wavelength microwave used in everyday circumstances are proven to be safe, right? So as I told you, there are very less harmful effects for microwave even. But ultraviolet exposure, it can be severe eye damage, can cause severe eye damage. Premature etching and disease can, you can say, have a skin cancer also a part of that as well. But remember that that happens when there is a excessive exposure to that. Then you can have X-rays and gamma rays. Now this is quite dangerous. This can cause the internal damaging of the body parts or mutation of the cells, which in the end can cause the cancer. So skin cancer can cause by that as well. Excessive use of X-rays or excessive exposure to X-rays and gamma radiation. Now, some of the communication. Now, remember that when you're talking about communication, there are different ways of the communication. The one of the ways of communication can be of satellite. This is called artificial, you can say artificial satellite. The artificial satellite you have. Now, they use microwave, right? There are two type of satellite majorly. Some satellite phones and direct broadcast satellite television use the geostationary satellite. Now, geostationary means a satellite which normally has a time period equal to Earth. Earth rotates on its own axis in 24 hours. So does this satellite as well. So this satellite is basically used for the communication purposes. So there is another satellite, we called it low orbit satellite. The previous one is used for the communication satellite, like in other countries, if there are matches and all that. Plus, this is used to get the information. Now, polar satellites orbit the Earth in north and south direction. These orbit much lower than the geostatic. Now, their distance from the Earth is less, 200 kilometers from the sea level, and used to monitor the weather, military application, and taking images of the Earth's surface. There are much shorter time delay for the signal compared to the geostationary orbits, right? So this is the way some of the some of the satellites will be used for different purposes. As I just told you, it is right there above the equator, and this is has a time period equal to the this height. It has a height of 36,000 kilometer above the Earth, right? And much higher than the polar. And what is the purpose for that? Telecommunication broadcasting worldwide. Next is system of communication. Now, remember that when you talk about a system of communication, the communication system will use the microwave. The reason is being a long wavelength, they can easily bypass the obstacles because the cities in our, in our case, are not empty. They have building. So wave has to bypass those. So for that reason, microwave is used. Plus, they have a large wavelength. So large wavelength waves are not being so dangerous and all that. So on the ground, mobile phone signal uses a network of microwave transmitter to relay the signals from the nearest mast to the receiving phone. Mobile phones and wireless internet uses microwave because microwaves are not reflected, right? So there are so many things in that. Radio waves are also definitely used for that. Now, radio wave can be used to transmit signals over a shorter distance. Radio wave have wavelength of around a kilometer, and radio wave can diffract. So it can diffract means it can just spreading out, right? So radio wave can diffract, and Bluetooth use the radio wave instead of wires and cables to transmit information between electronic devices over a short distance, right? Now, another very interesting thing is optical fiber. Optical fiber do use these radiations, especially infrared radiation, to carry the data. So data will be traveled within the optical center in the form of, you can say, infrared radiation. So these are the three things which are used to transmit the data. Radio waves, microwave, and then on optical fiber, you do use infrared radiations to transmit the data. Now, another small topic we have it is a sound. Now, what exactly is a sound? Remember that whenever you talk about a sound, sound is a longitude. Now, when it has a longitudinal wave, what does it mean is the waves are traveling parallel to the direction of the motion of the wave. You can see that some way the particle of the medium are very close to each other, some way they are a bit far from each other. So, where they are close, we call them compression. And where they are far, we call it rarefaction. Right? So this is what the sound is. Now, important few parts in sound is. What exactly it is? It has some qualities. The qualities are considered as pitch and loudness. What is meant by pitch? Pitch is everything to do with the frequency. Remember that. Frequency means, first of all, let's talk about the loudness. More the amplitude, more the loudness. Like here, the amplitude is less, so they have less amplitude. Here, it has a larger amplitude. So it has more loudness than this one, right? In this case, it has a more frequency because number of waves in a particular place is more. Here, number of waves in the same place is less. So more pitch, less pitch. Either more amplitude means more loudness. So loudness is everything to do with the amplitude, while frequency is everything to do with the pitch. Okay. So sound with a larger amplitude have a higher volume. Sound with a smaller amplitude have a low volume. Same thing. Sound with a higher pitch have a high frequency or a short wavelength. A sound with a low pitch have a low frequency. Right? So these are considered, these two, pitch and loudness, are considered as the qualities of a good sound. Then we have another small concept related. We call it echo. It is echo, technically speaking. Echo means the reflection of the sound from the hard surface. Like sometimes what happens when you say something, it comes back again and then it reflects back and it comes back again. So you hear one sound multiple times. What happened? The sound is keep on reflecting, 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 and you can hear the sound again and again and again and again and again. That is what we called as echo. So sound wave reflect off hard surface. The reflection of a sound wave is called as echo. Now, in this case, there is a formula to find the distance, how long the echo is going. 1 by 2 is speed into time. Why it's 1 by 2? It's the same formula which is saying uh, distance is equal to speed into time. But only thing is you divide it by 2. Reason is because the distance it goes and come back, that will be added into that, right? So that's why if you hear something, sound goes and come back, so that coming distance is also added into that. That's why you always divide the time it takes the sound to come back to your eyes, to come back to your ear by 2, because you just need to put the time it takes to go to that place, not to come back. Okay. So always you divide it by 2. So formula in case of echo is you always divide it by 2. Normally it's in the range, the speed is in the range of 330 to 350 for a sound, right? Now another very interesting concept is called ultrasound. Now, ultrasound, as the name suggests, ultra. Ultra means above. Now, remember one thing. We can see in this diagram that there are basically three things here. You have this sound. This is called infrasonic, ultrasonic, and in between that, you can see it's a human hearing. Remember that human can hear up to 20 hertz to 20,000 hertz frequency. That's it. not more than that. If it's even more than that, humans are unable to hear that. If it's less than that, humans are unable to hear that. So below is called as infrasonic, and more than that is called as ultrasonic. So ultrasonic are the high frequency whose frequency range is more than 20,000 hertz is called as ultrasonic, right? Now, what exactly some details related to that? What are the uses for that? Remember that there are multiple uses for that. For ultrasound, it can be non-destructive testing for the material it can be used for. It can be used for the medical scanning of a soft tissues. It also used in a sonar to calculate the depth, especially for the submarines and all that, right? To calculate the distance from time and wave speed. Now, how to actually calculate the speed of ultrasound? Now, same formula, if you check it out, to be used. For example, if a submarine wants to check it out, what exactly is happening, submarine just transmit us, or you can say ultrasound, right? And it receives, for example, after it strikes to some object, it comes back. So what happened? What will happen? It gives you a proper timing, right? But you have to divide that time by two because you just need to write the time it takes to reach to that object. So by using that formula, you can find out how much distance that object is away from the submarine, or you can easily find out how much depth. In case of depth, that can be found out as well. So depth of a boundary can be determined by using time taken between the ultrasound being emitted and received, and then you can use that formula. I already told you always divided by two because you just need a time that it takes to reach to that point. So 1 by 2 into speed into time will give you the depth, how much depth you will have, or how much depth through the material, right? So now, first point is it is used for the testing materials as well, checking for the cracks inside the metal objects and generate images from beneath the surface. For that purpose, you can use an oscillator for. So what happened? Ultrasound wave that reaches a crack in an object, such as a metal bar or a reflected back from the crack, earlier, then waves can continue to absorb through the object, and reflected waves are displayed as a pulse or as an oscillator. So what exactly is happening? First of all, you send that ultraviolet rate into the cracks. Some waves will be reflected back from the cracks earlier than the wave that continues to absorb. So some wave will be reflected, and that reflected wave can be shown on the screen. Okay? So this way you can find out exactly where there is a cracks and all that. Now, in case of medicines, you can find out it can be used to construct a fetus in the womb. Okay? It can give you three-dimensional, two-dimensional picture of that. As a medical treatment, it is used to removing kidney stones, right? The ultraviolet waves are reflected back to the transducer by the body. Transducer means the one that produces the ultra, because there are some objects that produces the ultrasound. Any wave has a transducer. Transducer is an object that produces. So transducer by boundary between the tissues in the path of a beam. Boundaries are between fluid and the soft tissues or a tissue. So what happened? Normally you have seen there is a jelly type material which is being used. So what happened? Transducer produces that wave. That wave will bypass into an object, and then what happened? Soft tissues and bone, there is a boundary. Okay. By taking the series of ultraviolet measurement, sweeping across an area, the time measurement may use to build up an image. So many of the other medical imaging technique, ultrasound is a non-invasion and believed to be harmless. Why it's harmless? Because it's all about sound waves. Okay. In case of sonar, as I just told you, this is also used. And in case of sonar, echo sounding can be used to measure the depth or to detect the object underwater, right? The sound wave can be transmitted from the surface. What happened? It strikes and reflect back. Once it reflect back, you can count the time, or you can calculate the time, how long it takes to come back. And then you can use the same formula which we have seen. Height is equal to 1 by 2 speed into time. You can use that and you can find out how much depth that object is. Okay. Remember that the distance you will find out is always twice the depth of an ocean. That's why you always need to divide it by 2. So that's how we end up to the section number 5, that is including waves and electromagnetic radiation. In the next class, we will start with the light, exactly, and we will see to it the reflection and refraction and other topics in more details. So if you have further discussion, if you want to further elaborate or want further discussion, detailed or further preparation for that, you can communicate, mix it, and we'll sort you out, hopefully. For further detailed lecture, communicate with the mixer. So hope to see you soon. See you in my next lecture, which will be lecture number 19. Thank you for watching.